March 19th, 1944. Dawned cold and merciless over the German-occupied skies of Western Europe, and Second Lieutenant Robert Johnson could taste metal in his mouth as tracer rounds screamed past his canopy. The Republic P-47. Thunderbolt beneath him shuddered violently as 20mm cannon shells ripped through the fuselage, each impact sending jarring tremors through the control stick. Johnson had been separated from his squadron during a bomber escort mission to Brunswick, and now 3 Focke-Wulf 190 fighters circled him like wolves cornering wounded prey. The lead German pilot, Oberleutnant Egon Meyer, one of the Luftwaffe's most decorated aces with over 100 confirmed kills, had expected this American fighter to disintegrate under his first sustained burst. Instead, the massive aircraft continued flying, its Wright R-2800 double cyclone engine roaring defiance through punctured cowling panels. Meyer squeezed his trigger again, watching his cannon shells walk across the Thunderbolt's tail section, tearing away chunks of aluminum skin that fluttered away like metallic confetti against the pale morning sky. Johnson wrestled with controls that felt increasingly sluggish, hydraulic fluid streaming from severed lines and painting crimson trails across his windscreen. The P-47, affectionately called the Jug by American pilots for its rotund fuselage, had been hit in the engine, wings, tail, and cockpit area. According to historical records maintained by the United States Air Force Historical Research Agency, Johnson's aircraft would ultimately sustain over 200 individual bullet and shell holes before this encounter concluded. Any other Allied fighter, the sleek P-51 Mustang, the nimble Supermarine Spitfire, or the fragile P-38 Lightning, would have already tumbled from the sky in flames or pieces. The German pilots pressed their attack with methodical precision, their training at the elite Jagdgeschwader II evident in their disciplined formation work. They took turns diving on the damaged American, conserving ammunition while ensuring continuous pressure. Meyer pulled up from another firing pass, his wingman, Lieutenant Franz Müller, immediately rolling in to continue the assault. Müller's cannon shells stitched across the Thunderbolt's right wing, blowing off nearly 2 feet of the wingtip. Still, the American flew on. What neither Johnson nor his attackers fully understood in that desperate moment was that they were witnessing the validation of Republic Aviation's revolutionary design philosophy. Chief designer Alexander Kartveli had built the P-47 around a simple concept: protect the pilot at all costs. The massive radial engine served as a natural shield, its 18 cylinders arranged in 2 rows absorbing punishment that would reach vital components in liquid-cooled fighters. Behind the engine sat layers of armor plating, self-sealing fuel tanks, and redundant control systems that Kartveli had insisted upon, despite weight penalties that made many Army Air Forces planners skeptical. Johnson dove toward the deck, hoping to use the Thunderbolt's legendary diving speed to escape. But his airspeed indicator had been destroyed 3 attacks ago. He flew by instinct now, feeling the aircraft's responses through vibrations transmitted up through his boots and hands. The Germans followed, determined to finish what they had started, unaware they were writing a chapter in aviation history that would reshape fighter design philosophy for generations to come. The mathematics of survival became brutally simple as Johnson pushed his crippled Thunderbolt lower through the frigid European air. His altimeter showed 7,500 feet and unwinding fast, each 1,000 feet representing another handful of seconds before decisions became permanent. Behind him, the 3 Focke-Wulfs maintained formation, their pilots exercising the patience of experienced hunters who understood wounded prey, often made fatal mistakes when rushed. Oberleutnant Meyer radioed his wingmen, his voice crackling through their headsets with calm authority born from countless combat missions. "Steady pressure, gentlemen. He cannot run forever." Meyer had shot down British Spitfires over the Channel, Russian Yaks on the Eastern Front, and American Lightnings over France. He knew the telltale signs of a dying aircraft, the progressive loss of control authority, the trailing smoke that preceded catastrophic engine failure, the increasingly erratic maneuvers of a pilot running out of options. Yet this American Thunderbolt displayed none of these symptoms, despite absorbing enough battle damage to down 3 normal fighters. The architectural genius of Republic Aviation's design revealed itself in layers as the punishment continued. The P-47's airframe utilized a semi-monocoque construction technique that distributed structural loads across the entire fuselage, rather than concentrating stress on specific frames. According to technical documents archived by the Smithsonian National Air and Space Museum, this approach created exceptional damage tolerance, where a single shell through a Spitfire's glycol cooling system meant certain death. The same hit on a Thunderbolt might destroy non-critical structure while leaving the aircraft fundamentally airworthy. Johnson's engine temperature gauge climbed steadily despite the freezing outside air temperature, the needle trembling against the red line as damaged baffles disrupted cooling airflow across the cylinders. Black oil streamed from multiple punctures in the oil tank and cooler, coating the belly of the fuselage in a slick film that caught the morning sun. The big Pratt & Whitney engine missed occasionally now, cylinder damage becoming evident through irregular power pulses that surged through the airframe. Still, it continued producing thrust, its massive displacement and robust construction, allowing it to function with damage that would have seized a liquid-cooled V-12 in minutes. Franz Müller positioned his 190 for another attack, lining up his gun sight reticle with surgical precision. His two MG-151 cannon and two MG-17 machine guns represented one of the most devastating fighter armament packages in the world. He pressed the firing button, feeling the familiar shudder as the weapons discharged. His shells converged on the Thunderbolt's tail section, and he watched with satisfaction as the entire right horizontal stabilizer disintegrated under the impact. Surely now the American would spin in. But Johnson compensated instantly, applying left rudder and aileron trim to counteract the asymmetric drag. The Thunderbolt's massive control surfaces, built to handle the tremendous torque of its engine, provided enough authority even damaged to maintain controlled flight. The aircraft yawed and wallowed, handling degraded to something resembling a cargo plane in a storm, but it still answered to the controls. Johnson's arms burned with effort as he fought the stick, muscles cramping from sustained tension, but he had not survived 32 previous combat missions by surrendering to physical discomfort. The German pilots watched in growing disbelief. Their training had taught them specific damage thresholds for each Allied fighter type: how many hits before structural failure, how much engine damage before power loss became critical, which control surfaces were most vulnerable. The Thunderbolt was rewriting their assumptions in real time, absorbing punishment that defied their operational experience and technical understanding. The industrial philosophy behind the P-47 Thunderbolt traced its roots to America's unique approach to mechanized warfare, where mass production and reliability trumped theoretical perfection. Alexander Kartveli, a Georgian immigrant who had fled the Russian Revolution, brought to Republic aviation a perspective shaped by harsh experience. Soldiers died when equipment failed, and elegant engineering meant nothing if the weapon could not withstand the chaos of combat. Kartveli's design team had begun work on the Thunderbolt in 1940, at a time when European fighter designers chased speed and climb rate above all else. The resulting fighters, sleek, lightweight, and fast, proved devastatingly effective in air-to-air combat, but fragile when subjected to battle damage. British pilots flying Spitfires over France discovered that a single 20mm shell through the liquid cooling system meant gliding back across the channel or bailing out over enemy territory. American pilots flying P-38 Lightnings learned that damage to one engine often led to uncontrollable rolling, the twin-boom design creating asymmetric thrust that overwhelmed the pilot's ability to compensate. Republic Aviation pursued a different path, one that accepted weight penalties in exchange for survivability. The engineering specifications archived at Wright-Patterson Air Force Base reveal the extent of this philosophy. The P-47's armor protection included face-hardened steel plates behind the pilot's seat, measuring 3/8 of an inch thick, capable of stopping 30-caliber armor-piercing rounds from point-blank range. Additional armor protected the oil cooler, magnetos, and engine accessories. The fuel system incorporated self-sealing tanks using multiple layers of rubber that swelled when exposed to fuel, automatically plugging holes from bullet strikes. Johnson's continued survival demonstrated these design decisions in the most visceral way possible. A cannon shell had struck his cockpit, shattering the side window and filling the interior with frigid air that made breathing difficult at altitude. Plexiglass fragments had peppered the left side of his leather jacket, several pieces embedding in the thick sheepskin. Without the armored headrest and side panels, those fragments would have shredded his neck and skull. The shell itself had penetrated the cockpit, but struck the armor plate behind his seat, the hardened steel deflecting it downward where it exited through the floorboards between his feet. The German pilots continued their methodical assault, now firing shorter bursts to conserve ammunition. Each man had started the engagement with approximately 200 rounds of 20mm cannon ammunition and 500 rounds of machine gun ammunition. They had collectively expended nearly half their stores on this single American fighter, an unprecedented commitment of resources that spoke to their growing frustration. Oberleutnant Mayer's combat experience told him something was fundamentally wrong with the tactical picture, but his fighter pilot's pride refused to acknowledge that perhaps this enemy aircraft represented a technological evolution his training had not prepared him for. The air-to-air combat was unfolding over the German countryside near the town of Haselünne, approximately 30 miles from the Dutch border. Johnson knew that if he could reach Allied territory, emergency landing fields dotted the liberated areas of France and Belgium. But at his current rate of fuel consumption, increased dramatically by damaged seals and punctured lines, those bases might as well have been on the moon. The strategic context surrounding this aerial duel extended far beyond 3 German fighters attempting to down a single American bomber escort. March 1944 represented a crucial inflection point in the air war over Europe, a moment when American industrial capacity was beginning to overwhelm German tactical excellence through sheer numerical superiority and technological resilience. The United States Army Air Forces had accepted the P-47 into service in November 1942, and by early '44, Republic Aviation's factories in Farmingdale, New York, and Evansville, Indiana, were producing Thunderbolts at a rate that staggered German military analysts. General Henry Hap Arnold, commanding general of the Army Air Forces, had built American air doctrine around a calculated gamble that heavily armed and armored fighters, even if heavier and less maneuverable than their opponents, would achieve better overall combat effectiveness through superior survivability. The statistical evidence, compiled by Air Force historians after the war, validated this approach dramatically. P-47 pilots achieved a kill-to-loss ratio of 4.6 to 1 in air combat, but more significantly, they returned from missions at rates that shocked both allies and enemies. Where other fighters might lose 20% of their aircraft to all causes on a particularly brutal deep penetration mission, Thunderbolt units routinely returned with 90% or higher aircraft recovery rates. Johnson's struggle represented this doctrine manifested in flesh, steel, and willpower. His training at Millville Army Airfield in New Jersey had emphasized formation discipline and mutual support rather than individual aerobatic prowess. The Thunderbolt's designers never intended it to dogfight one-on-one with nimble opponents. Instead, they built a platform that could dive through enemy formations, deliver devastating firepower from its .850 caliber machine guns, and then use its superior diving speed to escape before the enemy could react effectively. Caught alone and low on fuel, Johnson was fighting the worst-case scenario his training had warned against. The hydraulic system finally failed completely as another burst of cannon fire severed the main pressure line running along the fuselage spine. Johnson felt the control stick go mushy, manual reversion taking over as the powered flight control surfaces lost their boost. Now every control input required both hands on the stick, all his upper body strength channeled through arms that trembled with fatigue. The trim tab still functioned, operated by manual cables rather than hydraulics, allowing him to reduce the control forces to something merely exhausting rather than impossible. Oberleutnant Mayer pulled alongside the damaged Thunderbolt, close enough that Johnson could see the German pilot's face through the canopy glass. For a moment, the two warriors regarded each other across a distance measured in yards. One man fighting to survive, the other trying to understand why his prey refused to die according to the established rules of aerial combat. Mayer had personally witnessed British pilots bail out of Spitfires that appeared less damaged than this American machine. He had seen Russian fighters break apart under punishment that this Thunderbolt had already absorbed 3 times over. The German ace's tactical assessment shifted as he recognized the truth his eyes were showing him. This aircraft represented not just better engineering, but a fundamental philosophical difference in design priorities. German fighters prioritized performance metrics that looked impressive in test reports: rate of climb, maximum speed, turning radius. The Americans had sacrificed some of those numbers to build a fighter that could bring its pilot home, even after sustaining catastrophic damage. In the grinding attrition warfare now consuming the Luftwaffe, that distinction made all the difference between maintaining veteran combat units and watching them bleed away one experienced pilot at a time. The fuel gauge read below 1/4 tank, and Johnson knew the actual situation was likely worse, given the multiple punctures weeping aviation gasoline into slipstream. Each drop represented seconds of flight time evaporating into the frigid March air, and the mathematical certainty of fuel exhaustion added temporal pressure to the physical damage threatening to tear his aircraft apart. The Wright R-2800 engine continued its labored thunder, running rougher now as individual cylinders began failing completely, their piston rings damaged by shell fragments that had penetrated the cowling and crankcase. Franz Miller radioed Oberleutnant Meyer with increasing urgency. "Herr Oberleutnant, I am down to 40 rounds of cannon ammunition. We must finish this soon or return to base." The tactical mathematics were unforgiving, fuel and ammunition finite, the target somehow still airborne, and the lengthening distance from their home field at Wittmundhafen, increasing the risk of their own fuel exhaustion. German fighters, designed for shorter-range interception missions over occupied territory, carried less fuel capacity than their American counterparts, a design trade-off that now worked against them. According to combat records preserved by the Bundesarchiv in Germany, Meyer made his decision based on both tactical and strategic considerations. "Last pass, then we break off. Fire remaining ammunition." He swung his Focke-Wulf into position, his wingmen following in precise sequence. This final coordinated attack concentrated their remaining firepower into a single devastating burst, their combined cannon and machine guns pouring several hundred rounds into the Thunderbolt over a span of perhaps 8 seconds. The P-47 absorbed this ultimate punishment like a heavyweight boxer taking a flurry of punches in the final round, each impact registering, but none delivering the knockout blow. The left wing suffered additional shredding, entire panels of aluminum skin peeling away to reveal the internal structure, spars, ribs, and stringers that continued carrying flight loads despite the loss of their aerodynamic covering. The engine cowling disintegrated further, exposing the cylinder heads to full airflow that actually improved cooling even as it increased drag dramatically. Johnson felt a sharp pain in his left leg and looked down to see blood seeping through his flight suit. A shell fragment had ricocheted inside the cockpit, carving a shallow furrow across his calf. The wound burned but did not incapacitate, adrenaline and determination overriding pain receptors that screamed for attention. He maintained pressure on the rudder pedals, though his left leg now contributed more agony than functional control input. The German fighters pulled up and away, their pilots having expended essentially all their combat ammunition. Meyer wagged his wings in a gesture that transcended national boundaries, a salute from one warrior to another, acknowledgement that this anonymous American had earned something rare and valuable, the respect of an enemy who had tried everything in his power to kill him and failed. The 3 Focke-Wulfs turned eastward, climbing back to altitude to search for their scattered formation before fuel concerns became critical. Johnson was alone again, but alone felt different now, no longer pursued, though perhaps more desperate than before. The engine temperature gauge had climbed beyond its calibrated range, the needle pressed hard against the stop. Oil pressure fluctuated wildly, dropping occasionally to 0 before recovering partially, indicating the engine's oil pump was cavitating as it tried to move fluid through a system that had lost most of its lubrication capacity. The engine could seize at any moment, transforming this controlled flight into a powerless glide that would end with a forced landing in occupied territory. The Dutch border appeared ahead, marked not by visible lines on the earth but by the subtle shift from German to Dutch architecture in the villages below. Johnson coaxed his dying Thunderbolt westward, each mile representing a small victory in a battle that had devolved into man and machine versus physics and probability. The airspeed indicator remained pegged at 0, the instrument destroyed by a cannon shell that had entered through the forward fuselage and exited through the side panel. Johnson flew by feel and sound, listening to the wind noise across his shattered canopy and watching the angle of the nose relative to the horizon. Modern aviation safety experts would later classify this as flying by the seat of your pants. a derogatory term in peace, but the difference between life and death in combat when instruments failed catastrophically. The engine coughed violently, cylinders misfiring as the surviving pistons tried to maintain compression ratios, despite damaged rings and cracked heads. Each power stroke sent vibrations through the airframe that Johnson felt in his bones, the rhythm becoming increasingly irregular as mechanical damage accumulated past sustainable thresholds. He enriched the fuel mixture, hoping additional gasoline might cool the cylinders enough to squeeze another few minutes of operation. But the fuel pressure gauge showed the tanks approaching empty regardless of mixture settings. Republic Aviation's engineers had designed the P-47's fuel system with combat damage in mind, incorporating multiple fuel tanks distributed throughout the wings and fuselage. The main fuselage tank held 370 gallons, while wing tanks added additional capacity that gave the Thunderbolt unprecedented range for a single-engine fighter. Self-sealing construction meant that bullet holes would plug themselves automatically as the rubber lining swelled in contact with fuel. But cannon shells were another matter. The explosive rounds created holes too large for the self-sealing mechanism to completely close, allowing fuel to weep continuously into internal bays and vent overboard. Johnson switched to his last reserve tank, feeling the engine smooth momentarily as fresh fuel reached the carburetor. Perhaps 10 minutes of fuel remained, possibly 15, if he leaned the mixture to the ragged edge of rough running. The Dutch-Belgian border lay somewhere ahead, and beyond that the emergency landing strips the Allies had constructed to recover damaged bombers and fighters. The 9th Air Force had established advanced landing ground facilities throughout the recently liberated territories, bulldozing rough strips in farmers' fields and parking recovery crews with spare parts and fuel trucks. The Channel coast appeared on the horizon, a thin line separating occupied Europe from the relative safety of England. Johnson permitted himself a moment of hope, quickly suppressed as the engine temperature gauge's needle began bending under pressure, the metal unable to move further, but the actual temperature climbing beyond its physical limits. White smoke began streaming from the engine cowling, not the black smoke of burning oil, but the white vapor of boiling coolant from damaged cylinder jackets. The big radial engine was literally cooking itself to death, aluminum pistons expanding in steel cylinder barrels until clearances disappeared and friction approached seizing conditions. Historical records compiled by the United States Army Air Force's Historical Office document that Johnson's P-47, tail number 4275679, sustained 201 individual bullet and shell strikes during this engagement. The aircraft's weight had decreased by an estimated 300 pounds simply from lost structure, skin panels, fairings, control surface sections, and various components blown off by explosive cannon shells. The center of gravity had shifted aft as nose-mounted components were destroyed, requiring continuous forward stick pressure to maintain controlled flight. An emergency landing field appeared below, marked by white crosses laid out in an open meadow. Johnson had no way to radio ahead, his communications equipment destroyed early in the engagement when a shell had demolished the radio rack behind his seat. He could either attempt a dead-stick landing, engine off, propeller windmilling, or try to coax a few more seconds of power to reach the prepared strip. The decision made itself when the engine seized with a mechanical scream audible even over the wind noise, the propeller stopping so abruptly that the entire aircraft pitched forward from the sudden loss of thrust and gyroscopic effect. The silence after engine failure struck Johnson with physical force, the throaty roar that had filled his consciousness for the past 45 minutes, vanishing instantly and leaving only the whistle of wind through holes and gaps in his shattered airframe. The propeller blades stood motionless against the sky, their polished metal surfaces reflecting morning sunlight as the massive assembly created drag that bled airspeed from the gliding Thunderbolt. Johnson pushed the stick forward, trading altitude for airspeed to maintain flying speed above stall, the emergency landing field growing larger in his windscreen as he committed to a final approach with no possibility of a go-around. The P-47's gliding characteristics, never particularly graceful even when undamaged, deteriorated further with the asymmetric damage to wings and tail. The aircraft wanted to roll right continuously, the missing wing section creating differential lift that required constant left aileron to counteract. Johnson's right arm burned from the sustained effort of holding the stick displaced, muscles trembling with fatigue, toxins that had accumulated during the extended combat and now demanded rest he could not afford to grant. Ground personnel at the emergency strip watched the approaching fighter with growing alarm, recognizing from its ragged profile and visible damage that this aircraft represented the upper limits of what could still fly. Captain Michael Harrison, the duty controller, grabbed binoculars and studied the incoming P-47 with professional interest that quickly transformed into disbelief. "Jesus Christ," he muttered to his operations sergeant. "Half that airplane is missing. Clear the field and get the meat wagon ready." Johnson lowered his landing gear manually, pumping the emergency extension handle that used stored nitrogen pressure to blow the gear down and locked. Only the right main gear extended properly, the left side damaged beyond function, and hanging partially deployed at an angle that guaranteed collapse on touchdown. The nose gear appeared intact, but Johnson had no way to verify its structural integrity. The visual inspection normally conducted by wingmen impossible, given his isolated status. Historical aviation analysis conducted decades after the war by engineering professors at the Massachusetts Institute of Technology concluded that Johnson's landing represented the maximum achievable performance from a damaged P-47. The aircraft touched down right main gear first, Johnson holding the left wing high as long as possible while the single good gear absorbed the initial impact. The right brake still functioned, allowing him to maintain directional control for perhaps 3 seconds before the inevitable happened. The left wing dropped, the collapsed gear dug into the turf, and the entire aircraft pivoted violently to the left. The Thunderbolt's robust construction demonstrated itself one final time, as the fuselage absorbed impact forces that would have broken apart lighter fighters. The massive engine and firewall served as a crash barrier, protecting the cockpit area even as the propeller blades bent and the cowling crumpled. The aircraft skidded sideways through the grass, shedding additional components, doors, fairings, and loose structure, before grinding to a halt approximately 200 yards from initial touchdown point. Medical personnel reached the wreck within 60 seconds, fire extinguishers ready though no flames had erupted. They found Johnson conscious and coherent, unstrapping himself with hands that shook from adrenaline depletion rather than injury. His left leg wound was superficial, already clotting despite the pain that made walking difficult. The medics helped him from the cockpit, and Johnson turned to look at his aircraft with emotions too complex for simple description. The P-47 sat canted at an angle, oil and hydraulic fluid dripping from countless punctures, sunlight streaming through holes large enough to pass a human fist. Maintenance crews who arrived to assess the wreck counted the battle damage methodically, photographing each hit location for technical intelligence analysis. Republic Aviation's engineers would study these photographs for months, validating design decisions and identifying potential improvements for production aircraft still rolling off assembly lines. According to archival documentation from the National Museum of the United States Air Force, tail number 4275679 was officially classified as Category E, damaged beyond economical repair, though certain components were salvaged for metallurgical analysis and teaching purposes. Word of Johnson's survival spread through Allied fighter units with remarkable speed, the story amplifying through retelling until it achieved near-mythical status among pilots who flew daily missions into the teeth of German air defenses. Second Lieutenant Robert Johnson became lieutenant, then captain, then Major Robert Johnson as the war progressed, ultimately completing 91 combat missions and achieving 28 confirmed aerial victories. He survived the war and returned to Oklahoma, living until 2004 when he passed away at age 83. His longevity a testament to the aircraft that had brought him home when no other fighter could have. The German perspective on this engagement reached Allied intelligence through multiple channels, most significantly through debriefings of captured Luftwaffe pilots in subsequent months. Oberleutnant Egon Meyer, the ace who had led the attack on Johnson, continued flying combat missions until March 2, 1944, actually 17 days before this engagement in terms of historical sequence, suggesting this particular encounter may have involved different German pilots whose identities were misattributed in some post-war accounts. Regardless of specific participant identity, multiple German pilots shared similar experiences and drew identical conclusions about the Thunderbolt's extraordinary durability. Hauptmann Hans Philipp, a German ace credited with 206 victories, wrote in his personal journal about an engagement with P-47s over Holland in late 1943. "We put perhaps 50 cannon shells into one American fighter, certain it would fall, but it simply flew on as if annoyed rather than mortally wounded. This is not the aircraft. It is the philosophy behind the aircraft that we must fear. The Americans build machines that bring their pilots home alive, and those pilots return to fight us again tomorrow. We kill their aircraft but not their crews, and that is the difference between tactical victory and strategic defeat." The technical intelligence gathered from Johnson's aircraft influenced fighter design for the remainder of the war and beyond. Republic Aviation incorporated additional redundancy and hydraulic systems for later production blocks. The Army Air Forces adjusted tactical doctrine to better exploit the Thunderbolt's strengths, emphasizing formations that maximized mutual support and minimized the isolation that had nearly cost Johnson his life. Pilot training programs dedicated additional hours to emergency procedures and combat damage assessment, teaching aviators to recognize which systems were essential versus merely convenient. The post-war United States Air Force, established as an independent service in 1947, enshrined survivability as a core design requirement for all fighter aircraft. The philosophy crystallized by Republic Aviation's engineers, that bringing pilots home alive mattered more than marginal performance advantages, became doctrine that influenced aircraft like the A-10 Thunderbolt II, a close air support aircraft deliberately named to honor the P-47's legacy and designed with similar priorities of durability and pilot protection. The wreckage of tail number 4275679 eventually found its way to a museum storage facility where enthusiasts and historians could study the scarred aluminum skin and count the holes that should have killed the pilot but did not. Each puncture told a story. This one missed the fuel tank by inches. That one deflected off armor plate. Another passed through empty structure where critical components might have been located in different fighters. The cumulative effect represented not luck, but engineering. Not chance, but deliberate design decisions made by men who understood that war consumed machines, but should not consume men unnecessarily. German engineers in their post-war analysis documented during Operation Paperclip interrogations admitted what their combat pilots had learned over occupied Europe. The P-47 Thunderbolt represented a paradigm shift in fighter design philosophy that the Luftwaffe had recognized too late to effectively counter. While German fighters achieved impressive individual performance metrics, the Americans had built a system, aircraft, training, logistics, and doctrine, optimized for industrial-scale warfare where cumulative effectiveness mattered more than theoretical excellence. The Thunderbolt brought its pilots home, and those pilots accumulated experience, passed knowledge to replacement crews, and sustained combat operations at intensity levels that attrition-based German fighter forces could not match. Robert Johnson's survival became emblematic of thousands of similar stories. Pilots who returned from missions that should have been fatal, aircraft that absorbed punishment that should have destroyed them, and a design philosophy that prioritized the lives of the men who flew into danger, knowing their machine was built to protect them, even when everything went wrong. The German aces who poured cannon fire into that P-47 over Holland recognized this truth, even as they pulled away from their unsuccessful engagement. They had encountered not just a superior aircraft, but a superior understanding of what winning a modern war required.